Hello, grade 7 students. It's another great day to learn more. I hope you're doing good today. Welcome to our Physical Science 7, Quarter 3, Week 1. Have you ever wondered why things around us are moving, or changing place, or even just changing position? I know you've been asking that since your childhood. Today, that will be our exciting topic, describing motion. So, get your pen and paper, your self-learning module, and your weekly learning activity sheet. And together, let's describe motion.
Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone.
In this lesson, you will define motion. Describe the position of an object to a point of reference and direction. You will also describe the motion of an object in terms of its distance. Differentiate distance from displacement and describe the motion of an object in terms of its speed. My dear grade 7 students, as we go along with our lesson, don't forget the following words with its meaning. Motion is defined as the process of something moving or changing place, or even just changing position. It is also defined as the change in position for a particular time interval. That means that everything around us that's moving is caused by motion. Isn't it amazing? Point of reference refers to place or object used for comparison to determine if something is in motion, while distance is the length of the entire path that the object traveled, and displacement is the shortest distance between the object's two positions, like the distance between its point of origin and its point of destination, no matter what path it took to get to that destination. On page 4 of your weekly learning activity sheet, you can see different diagrams. Now let's try to understand the concept of distance with the help of the following diagram. Are you still following me? Very good. Try to look at figure 1, distance and displacement. Total distance is d equals to d1, that's distance 1, plus d2, distance 2. You will just add your distance 1 to distance 2. As you can see on figure 1, imagine myself standing under a small tree. My distance towards the house in front of me, that's point B, is 4 meters. Another tree, that's point C, the bigger one, is 3 meters. Distance here will be my point, which is point A, to that house, point B, is 4 meters, plus distance to point B from the house to another tree, that's 3 meters. You will just add d1 plus d2 to get the distance, which means 4 meters plus 3 meters equals to 7 meters. The displacement here will be the distance from the starting point A to the final point C, that is me under that small tree, to point C, the bigger tree, which is 5 meters. Displacement is the distance from A to C, that is 5 meters northeast. Now let's have another example. In figure 2, you can see a dog running. The dog ran 10 meters to the east, then 5 meters to the south, and another 10 meters to the west. How much did it travel? What is the total distance it traveled? Yes, the dog traveled a total distance of 25 meters. Again, that's 10 meters to the east, 5 meters to the south, and another 10 meters to the west. In getting displacement, it is by measuring the distance between the initial position and the final position of the object. And based again on the figure 2, the dog's displacement is 5 meters to the south. In figure 2, distance traveled by the object is represented by broken lines, while displacement is represented by continuous line. Always remember that in getting displacement, you need to measure the distance between the initial position and final position of the object. As easy as that. I know you want more illustrations. On page 5, there are more examples provided. Figure A shows a ball, while figure B, a car traveling, and figure C, a dog running to a house. Let's try to see the difference between distance traveled by an object and its displacement. Speed refers to distance traveled divided by the time of travel. Speed, that's equals to distance traveled. D. Time of travel, T. The speed unit can be miles per hour, kilometers per hour, or meters per second. Say for example, a girl runs a distance of 3 meters in 10 seconds. What is her speed? Speed is equals to distance divided by the time. That means the speed of the girl that is running is 3 meters divided by 10 seconds. So the speed is 0.3 meters per second. Did you get it? Very good! For you to understand more our lesson for today, let's start with our activities. Let's have activity 1 entitled Fill Me In. I know it will be very easy for you. On the box on page 6 of your weekly learning activity sheet, you can find words that are needed to fill in the blank to complete the sentences. The choices are again provided inside the box. The words are motion, point of reference, distance, displacement, and speed. Are you ready? Let's start. Number 1. You can measure blank by dividing distance over time. Very good. The answer is speed. You can measure speed by dividing distance over time. Number 2. Blank is a change in an object's position as compared to objects around it. Great! The answer is motion. Motion is a change in an object's position as compared to objects around it. Number 3. The objects you use for comparison become your blank. Wonderful! Point of reference. The objects you use for comparison become your point of reference. Number 4. Blank is a measure of the distance an object travels in a certain amount of time. Good! The answer is speed. Speed is a measure of the distance an object travels in a certain amount of time. And number 5. Blank refers to the shortest distance between the object's two positions. Great! The answer is displacement. Displacement refers to the shortest distance between the object's two positions. We're not yet done. Let's proceed to activity 2. Where is my position? Try to look at figure 4, positions of different objects on page 6 of your weekly learning activity sheet. Letter A. Direction is, analyze the diagram to complete the table below. You can see the position of a dog, a house, and a tree. Let's try to answer what are the positions of different objects. Position of the dog is already given. Can you answer what's the position of the tree? Very good. The tree is 5 meters. How about the dog with respect to the house? Great. That's 25 meters. And the tree with respect to the dog? Very good. That's 15 meters. Wow, you got it all correct. On page 7, try to look at figure 5 with the moving ball, with its time indicated as the ball travels. The questions are, number 1, what is the initial position of the ball? Question number 1, what is the initial position of the ball? Of course, very good, that's 0 meter. How about its final position as it travels along? Yes, that's 15 meters. Number 2, at 10 seconds, try to look at the figure. What is the position of the ball? Great! At 10 seconds, the ball travels 10 meters. Number 3, give the exact time where the position of the ball is equal to 5 meters. Wonderful! That's 5 seconds. This time, on your weekly learning activity sheet, you try to construct a graph using the data in figure 5, that is the moving ball, with a time indicated as the ball moves. Let's fill up table 2. Now in 5 seconds, how far did the ball move? Very good, 5 meters. How about in 10 seconds? Yes, 10 meters. And in 15 seconds, the ball traveled 15 meters. Very good. Now, can you plot the values in table 2 as points on the graph in figure 5? Note the time is plotted on the x-axis while position is plotted on the y-axis. Do it now! Let's have another exciting activity. Activity 3, entitled Ducky Distance. I know you're familiar with ducks, so let's answer figure 7, the duck's distance. Let's analyze the diagram on page 8 of your activity sheet as the duck travels. Can you still follow? Very good. What is the distance traveled by the duck from point A to point B? Very good. The duck travels 5 meters from point A to point B. How about point B to point C? Very easy. That's 1 meter. How about point C to point D? Great, that's 5 meters. So, what is the total distance covered by the duck? Wonderful, the total is 11 meters. Now try to follow me for our activity 4, distance versus displacement. That's page 9 of your activity sheet. Let's try to answer the following problems relative to distance versus displacement. Can you see the figures of path 1, path 2, and path 3? Very good. Now let's answer number 1. Suppose you run 3 different paths from A to B. Along which paths would your distance traveled be different from your displacement? Very good. That's path 1 and path 3 because they are moving on different ways. Number 2, you run from your house to a friend's house that is 3 meters away. You then walk home. What distance did you travel? Of course, that's 6 meters. What was your displacement? It's 0 meter. Why? Because the distance you traveled running from your house to your friend's house is 3 meters. You just walk home with the same direction, that is still 3 meters. 3 meters plus 3 meters equals to the distance, which is 6 meters. Let's have the last activity, speedy speed of activity 5. Let us solve the following problems. A boy walks 25 meters in 3 seconds. What is his speed? Very good. The speed of the boy is 8.33 meters per second. Why? Always remember that speed is equals to distance divided by time. So, 25 meters divided by 3 seconds, that is his speed, 8.33 meters per second. Isn't it easy? Very good. Number 2. A car travels a distance of 45 kilometers in 3 hours. What is the speed of the car? Great! The speed is 15 kilometers per hour. 45 kilometers divided by 3 hours. That is the speed the car travels. That's a wrap! That ends our lesson for today. I know that you had fun solving our different problems. Very easy, right? That is how we describe motion. This time, I know that you can define motion, describe the position of an object to a point of reference and direction. I know also that you can now describe the motion of an object in terms of its distance. Differentiate distance from displacement, and describe the motion of an object in terms of its speed. Very easy! That ends our lesson for today. My name is Teacher Young, and together, let's continue exploring the world of science. Until next time, don't forget to always be cheerful and strive to be happy. Bye!